this snippet, we talk about how to segment your data by row label. So recall that all these symbols are organized by stock symbols. So there's a bunch of dates, but then you can also see there are a bunch of stock symbols. So we want to query just the Apple stocks and the Google stocks and these ones. So what you want to do is use the double bracket notation. You want to say, okay, look into the data frame, but only if this condition is true. Like this sub data, this temp table, turn whatever is in this bracket into my new data frame, right? And what's in this bracket is first is saying, look at the symbol column of my data frame and only take it if the symbol is Apple. And so we're supposed to get a bunch of new data frames, and when I print out the shape, they all have 7 features, and they have 1,662 rows. And here I just rename them and store them in the right variable. And here I did a dot describe to get basic statistics, and you can see the count are supposed to be pretty similar, except I think it's supposed to be pretty similar. This volume is much higher though, but oh no, it's just the count. Okay, it's the same. Okay, mean you should see that the volume is high because sometimes stocks trade for Twitter IPO $3 million volumes a day versus the price shouldn't be that high, right? You don't have $3 million stocks, except Berkshire Hathaway has like pretty expensive 500K or something. So you can see the means are pretty similar for everybody, right? And the standard deviation is pretty similar, but that's not what we want. Really, I didn't do a good job here. I should have done this. Apple describe, and then Google describe, and then Netflix describe. So this is the Pandas function. It's very handy. Okay, so you have to, it only returns the last row. So if you want to see everything, you have to print it out. So we can see the counts are supposed to be very similar across the board. Excellent. And then I guess all the columns are using scientific notation. That's why we see this one looks different, but it's the same. And then we have, Apple did stock split. That's what the adjust close price means. At one point, Apple was actually really expensive, like Google. Now it's much cheaper, around $100, because they did a 7-to-1 stock split. In fact, they did multiple. So they divide the price by 7, and it give people extra shares and dilute the whole pool, yada, yada. So that's what the adjust close is about. It's about dividends, about taking into account stock splits. And Google, as you know, was much higher. It was like hovering 500, 700 now. And standard deviation is much more too. So you see a difference. And the last one is Netflix. And Netflix is obviously has lesser value than Apple as a company. So you see the numbers being smaller. And the 75th percentile, we have 102, we have 578, and 68 here. And this is why there's such different scales. This is why we want to normalize them. Right, you have volume that's super high, super high in the millions, or sometimes in the 500,000. That's too high for your stock price. You have 48, you have 500, you have 100. So that's why the min max scalar will be very important later. So we'll do that later. And here's a nifty function. You can return you can return and print out all the symbols that are in your spreadsheet, so you can get an idea without that's why Pandas magical, right? You can do this pretty quickly, see, oh, it's not just Apple, Google, we're actually dealing with everybody here. And you can double check your data frame just to make sure you're getting all Apple's data here, right? So let's comment this out. These are all my testing statements. It doesn't have symbols, which makes sense because this is why. Oh, it does. So it should work. Symbol, sorry, extra S. Okay, and you should get all Apple just for testing. So here you go. Very nifty, very useful Panda functions. And the next one we will go through how to check if there's NaN, not a number, and handle data integrity.